What's up guys, Onmaths here, and today we're looking at three-dimensional right angles. So this is any question that involves a triangle that is trapped inside a three-dimensional shape. Okay, so we've got a cuboid here, and we're given some angles on this cuboid and some lengths, but unhelpfully they're not actually on the diagram itself, and they probably do that just to kind of free up the space in the diagram for you to add kind of lines to it. And we're asked to find the size of the angle between AH and the plane ABCD. So let's mark on AH first. So AH is just a line from A to H. So it's a kind of diagonal line across the cuboid. Now the plane is going to be this bit down here. So this kind of face down here. And if you look at the kind of angle of AH, we need to kind of show that as a line so that we can work out the angle. And the way of doing that is it's just going to be the line AC. So if you see that, that makes now a right angled triangle. So if I just show the last kind of length of that right angled triangle and put my right angle in. Okay. Now the problem is I don't have the length of line AC, because if you look, we've given AB and CH, so we've kind of got to work that out. Now CH is useful because that's 8.1, so that will be useful for when we get to the end of this question, and the question's all about this angle here. So we are given length AB, and so if we're given length AB, we're kind of given this one here, and that says it's 7.3 at the back here. And we are given angle BCA, so if I draw another, let's use black this time, if I draw another line here, then, in fact, let's just make that a bit nicer. Oops. It's going to start moving things, isn't it? Let's just draw a freehand for now. So it's this length here, we're not given, but this angle here, and I'll put this angle outside, this angle we're told is 48 degrees. So if I draw that right angle triangle, because it's a cuboid, this is going to be a right angle here. And if I draw that out a bit like bigger, so that we can kind of see what we're doing. So this is length AB here, this is length BC, and then this is the diagonal length. Whoops. This is the diagonal length here. So we know that this is 7.3, we know this is a right angle here, and we know this is 48 degrees. And we know we need to find length AC so that we can complete this question. So we're looking for length AC, which I'm just going to call X just for simplicity. So we've got ourselves a right angle triangle. We've got two lengths and an angle involved in the question, with one of the lengths being unknown. So we know we're going to be using trigonometry. So we're going to put in our SOHCAHTOA, label the sides, so the opposite the angle, opposite the right angle, and the one left over, cross out the one we're not using, OH. So it's going to be sine the angle 48 equals opposite, which is 7.3 over x, and then what we can do here is just swap the x and the sine 48 around. Technically we're timesing both sides by x and dividing both sides by sine 48, but you are allowed to do this in one step. And then I'm going to put that into my calculator. So 7.3 over sine 48, make sure we close that bracket, and that's 9.823118.926. The reason I'm writing down as many numbers as I can is that this is not our answer, this is just our kind of halfway answer. So we know that red one there is 9.82 blah blah blah. But I should put it in red just to make sure it's obvious. So that's 9.82 blah blah blah. Now, just to note that obviously on the exam you can't use different colours. You've got to all do it in pencil and pen, and I think it's black pen or blue pen, depending on the exam board. So I'm just basically doing this just to highlight the areas a bit easier, just to explain it. So we're going to draw that central right angle triangle now. And I'm using the same colours just to kind of show you which one it is that we're drawing. Ooh. Okay, so the height is 8.1. We now know this length here is 9.82, blah, blah, blah. And I've kept it in my calculator. And we're looking for this angle here. This angle I'm just going to call Y, just to help with the working out. So we're going to use Ocr again. And the hypotenuse is going to be opposite the right angle, opposite is going to be opposite the marked angle, which is Y in this case, and the adjacent is the one left over. So we don't need the hypotenuse, so it's going to be tan. So we're going to write tan Y, tan the angle, equals the opposite, which is 8.1, over the adjacent, which is 9.82, blah, blah, blah. Now I'm going to inverse tan both sides to find out what Y is. But I'm not actually going to work out that bit yet, because I've still got the 9.8 in my calculator and I'd love to keep the precision up. So I'm just going to work out what the whole calculation will be first. So on my calculator I've still got the 9.82 blah 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 up, and I'm just going to click inverse tan and then fraction 8.1 over, and I'm just going to click answer. I'm going to click out and just close that inverse tan bracket. Press equals, and it says it's 39.50849, blah, blah, blah. Check to see if it wants it to a degree of accuracy, which it does, 1 decimal place. So my answer will be 39.5 to 1 decimal place. Next on to our AQA question. Now, as you might have gathered from the previous question, I always try and draw out the 3-dimensional right angle triangles as 2-dimensional triangles, just because it makes things so much easier when I'm checking my work later on, checking I've got all the right measurements. So this question from AQA involves a triangular prism, but the same rules kind of apply. And we need to show that EM is 15 centimetres. So a few things to note: that AB is 16 centimetres, so we can label that on. I'm not going to put the units because all the units are the same, they're all in centimetres. AE is 17 and BC is 30. I'd probably just label those onto the diagram, but leave plenty of space and don't do them inside the shape, because I might need to do some kind of 3-dimensional lines. Okay, so M is the midpoint, so what I can do is, instead of that being 16, I can just halve it, so that would be 8 and 8. It's a better way of thinking about it, because we're showing EM, which is this line here. Okay, so if I have a look, we've got a nice little right angle triangle here. Okay, so if I just draw out that right angle triangle, I probably don't need to because it's pretty clear already, but I will anyway. And that's right angle, and it shows on the diagram it's right angle on the other side. So we've got 17, 8, and we'll call this X for now. X describes the length EM. So we've got a right angle triangle, and we've got 3 lengths. One of them is unknown, so that's definitely Pythagoras. So we write down a squared plus b squared equals c squared. A and b don't matter which way around they are, so we'll do, I don't know, x squared plus 8 squared, but c must be the hypotenuse. So we're just going to put our lines in, although there's not an awful lot of space, but we'll manage, maybe. Take away the 8 squared from both sides, and we've got x equals, or x squared equals 17 squared minus 8 squared, square root both sides, and we've got x equals, so I'm going to type that in, so square root of 17 squared minus 8 squared, and that equals 15. Okay, so that's good working out. I probably in here should show the working out that x equals square root 17 squared minus 8 squared, because that's what they'll be looking for. So just make sure you probably put that step in, mostly because it gives you the answer in the question, so try not to miss out any of the stages of the working out. The next question will ask us for angle ECM, so we need to create a triangle for ECM. So let's draw a line from E to C, and then another line from C to M. Now, looking at that triangle, we're missing 2 lengths. So we haven't got EC or MC. We do have EM from the previous question, which is good. So we know that that is going to be 15. But for working out an angle, we need 2 lengths. So we're looking for this angle here, and we've only got 1 length. So EC is going to be a real tough one to find, I'd imagine. So I'd probably look at MC, and the reason I'd look at MC is we're kind of halfway there anyway, because we know, so if I draw it in, we know MB, and I'm running out of colours here, and we know BC, so we can just work out MC from MB and BC. So let's do that. Okay, so let's draw our right angle triangle, but as a flat shape. And that's MB, that's BC, and then this will be MC. They don't line up perfectly, but let's just try and maybe sort that out a little bit. Okay, let's put on the lengths. So we know that's 8 there, and we know that's 30, and we're looking for that, so we'll call that X. This will be a right angle, just from the fact that the bottom of a triangular prism is a rectangle, so we know that rectangles have right angles, so that right angle is that right angle there. Okay, so we're going to do Pythagoras again, so a squared plus b squared equals c squared. This time the a and b are known, so it's 8 squared plus 30 squared equals x squared. Then we're going to square root both sides, so get my lines in, and we're just going to square root both sides. So x will equal square root of 8 squared plus 30 squared, and so therefore x will equal, let's put that into our calculator, square root of 8 squared plus 30 squared, and it kind of gives us a choice of 2. It gives us a nice third or a horrible decimal. So I could just leave it as the nice third that it gives me on the calculator, or otherwise I could leave it as a decimal 31.04834. The reason I'd leave it as a third is it keeps the precision, so that's quite a nice way of making sure you're not rounding too early. So we know what x is now. I'd probably label it on the diagram. So we know that's 2 root 241. Okay, x is MC, don't forget. And we're looking for angle ECM. So let's draw in this shape again. And so we've got I'm running out of space here. Let's do it here. Maybe make it a bit bigger. Okay, this one here, and then we've got the final one here, and we know that's 15, and we've just worked this one out, 2 root 241, and then we're looking for this angle, which I'm just going to call Y. Okay, so we know we're going to be using trigonometry for this, because we've got a right angle triangle, and we're given 2 lengths, and we're looking for an angle, so it involves 2 lengths and an angle. It's definitely trig. So let's get our SOHCAHTOA in. Let's label the sides. So we've got hypotenuse opposite the right angle, opposite the marked angle, and adjacent there. You're not using the hypotenuse, so therefore it's going to be tan. So we're going to have tan the angle, which is y, equals, and then its opposite, which is 15, over adjacent, which is 2 root 241. Then get our lines in because we need to inverse tan both sides. And again, I'm just going to do all the working out first because I've still got that 2 root 241 on my calculator, and so I can just use the answer button on the calculator and just make sure I keep that precision. Okay, so to find out y, I'm going to do inverse tan fraction 15 over answer, come out of the fraction, close that bracket, and I get 25.7859 blah blah blah, which equals, it doesn't say to give a specific rounding, so I'm just going to pick 3 significant figures, 25.8 to 3 significant figures. Now I should really say that this is angle ECM, because I've kind of called it Y, but I should really make it really clear to the examiner that that's, and in fact there's an answer field here, so I can actually just put it in the answer field. It should be clear to the examiner that I've just labelled it Y just to keep the length of the working out down, because if you're writing a whole load of letters or angle ECM every time, it does add to the amount of working or the amount of writing you need to do. Last up is our OCR question, and in this question we've got a cuboid, and we are told that we're going to put a stick of length 95 centimeters in it so that the shortest possible length extends. So we've got to completely fill this cuboid with this stick, and we don't want much to poke out the end. And the way of doing that straight away is the biggest diagonal. It doesn't matter which diagonal you pick, but the reason I've picked this one is it's the closest. In fact, let's just do that again because it's a little bit off. Is that better? Slightly better. It's the closest to all of the length, so you could pick any diagonal, and any diagonal in a cuboid will give you the same length. So with this one, what we want to do, it's because it's a square at the bottom. With this one, what we want to do is use Pythagoras, and so what we need to find is this length here first, and so I'm just going to quickly get the right angle triangle drawn. This is the right angle here. And the reason I'm doing this quite quickly is we've kind of done this on previous questions. Now I'll call that x, and then we're going to do a squared plus b squared equals c squared. So it's going to be 46 squared plus 46 squared equals c squared. And get my lines in. And then I'm going to square root both sides. So we've got square root of 46 squared plus 46 squared equals c. And so c equals, and then get my calculator, square root of 46 squared plus 46 squared. And that gives us a nice surd to use, 46 root 2. Okay, and then we're going to draw in the other right angle triangle to be able to answer this question. And so that's going to be the 55, and then the one we've just worked out, and that will give us the diagonal. So the 55 there, 46 root 2 there, and then we're going to call that, I don't know, y. A squared plus b squared equals c squared. A and b, 55 squared plus 46 root 2 squared equals c squared. And I'm probably just going to move this because I'm going to run out of space. Move that up there. Get my lines in. Square root both sides. So it's going to be the square root of 55 squared plus 46 root 2 squared equals c. And I've still got that on my calculator, so what I can do is square root 55 squared plus answer squared, and that says that C equals 85.18802 blah blah blah. And what we need to do is we need to take that away from the 95, because it says calculate the length of the stick that extends outside the crate. So it's 85.1 inside the crate, so we just do 95 take away 85.18 blah blah blah, and all I'm going to do on my calculator is 95 take away the answer, and that gives me 9.81197 blah blah blah, and we'll round that to, I don't know, 3 significant figures, 981. We'll show you rounding, 9.81. Now there might be some of you who are screaming at the video going, there is another formula, and there is, and I'm going to tell you about it now. The formula is length of diagonal equals square root of length squared plus width squared plus height squared. Okay, so if you just do the square root of whatever, it doesn't matter which order we do these in, I'm just going to do them in any order, and we type that into our calculator. So square root 55 squared plus 46 squared plus 46 squared, we get the answer of 85.188, which is the answer we got before, which is here. Okay, now there are two reasons I didn't do it that method. The first reason is that I wanted to show that you can do it just using Pythagoras, so you don't have to learn this extra formula, although if you use that formula and you understand it and you're happy with it, go for it. The other reason why I've not done it that way is if you have a look at question B, we're looking for the angle the stick makes with the base of the crate. So we're going to have to work out that red one anyway, the 46 root 2 anyway. So it just didn't seem like it was saving us really that much work. But really well done if you knew the formula that I've just written on screen. Okay, so for this next one, we're going to draw in the diagram. Now, we're going to ignore the 95 centimeters, because we don't have, and I'll just show you on the diagram, we don't have this length here. Whoops. We don't have this length here, so we can't really use that 95 centimeters, but we can definitely use the 85.18802 length and the 46 root 2 length that we found. So we're going to draw the diagram in again, and so we've got length going down, green and red, so green and red. Good thing my green doesn't match up. Maybe just extend them a little bit. Okay, so we've got the 46 root 2 at the bottom that we worked out in the previous question, and the marker will look at your previous question for working out, so don't worry too much about where your working out is. We've got the 55, and actually, thinking about this, we could have just used that y value, but there we go. So you could have just used the root 55 squared plus 46 squared plus 46 squared, because we don't need 3 lengths. So we're looking for the angle it makes with the base of the crate, which would be this one here, and we're going to call this x. And then we just use Ocr, so that's going to be the hypotenuse. In fact, let's just do a different colour. That's going to be the hypotenuse, the opposite and adjacent, cross like that. Ocr. And so we're going to be using tan, so it's going to be tan x equals the opposite, which is 55, over the adjacent, which is 46 root 2. Then we're going to have our lines in, because we're going to inverse tan both sides. And then we've got inverse tan of 55 over 46 root 2. And so let's type that in. So inverse tan fraction 55 over 46 root 2, and I get the answer of 40.2129 blah blah blah, and we're going to round that, kind of run out of space here, to 3 significant figures. So we're going to write in 40.2 as our answer. So just to be clear on the question B, we could have used the hypotenuse of 85.188 and used sine with the 55. We could have actually used the 46 root 2 and the 85.188 and used cos. I would always use the numbers in the question, definitely, because you know that they're right. And so, yeah, I'd always use that 55. But if you didn't know that formula, it is really useful because, like, for a 4-mark question, just doing the square root of 3 squareds and then taking it away from 95 is the easiest 4-mark question you're ever going to get on the exam, especially at, I think this is the last question on the paper. But using a couple of Pythagoras, it's not so bad either. Well, I hope you found that video useful. If you did, please click like. Keep your comments coming in for stuff you wanted us to do after summer school, which unfortunately is now, although I might do a bonus video tomorrow on iteration, because I've not really talked about that. It did come up in one of the topics, but I didn't really go through it in the video because there were so many other questions to do on accuracy. So there might be a bonus video, but keep your comments coming in. Let us know what you want us to cover. We are planning on releasing videos regularly after maybe a bit of a break. So keep subscribed so that you're up to date with when we start putting videos out again. If you haven't already, which I'm sure you have, you can click the link at the top of the video now and it will take you straight through to our website, onmaths.com, which is packed full of completely free resources to help you with your maths. Otherwise, thank you very much, and I'll see you later.